In 2003, a stock exchange in Asia went offline for almost an entire day. The reason? A single cable failure in their star-shaped network took down thousands of trading terminals at once. Millions were lost. That's the power of a network topology, the shape of how devices connect and why it can make or break entire systems. Hi guys, I'm DHT Ghost and welcome back to the DHT Ethical Hacking Mega Course. Episode 15, Network Topologies, the Shapes of Connections. Today we'll uncover how the physical and logical maps of networks determine speed, reliability, security, and even how hackers exploit them. D'Arturi, what is network topology? Network topology is simply the arrangement of devices and cables in a network. Think of it like city planning. The roads, highways, intersections are network links, houses, offices, stations are devices. How you design the map determines whether traffic flows smoothly or collapses under stress. The main types of topologies. 1. Bus topology. All devices connect to a single backbone cable. Cheap, simple, but one cut in our whole network down. Like an old single street where every house is lined up. If the road is blocked, no one moves. Yet our star topology. Every device connects to a central hub or switch. Easy to manage, scalable, but if the hub fails, everything fails. Imagine a shopping mall with all shops linked to one main hall. Ring topology. Devices form a loop, each connected to two neighbors. Data travels in one direction or both in dual rings. Faster for small networks, but a single break can disrupt flow and less redundant. Like a circular train track, one broken rail, whole train stops. Mesh topology. Every device connects to many others. Extremely fault-tolerant, or if one link fails, traffic reroutes. Expensive and complex, used in military backbone networks. Think of airline routes where cities have multiple flights to each other. Tree hierarchical topology. A mix, groups of star networks connected together. Used in enterprises, scalable, organized. Like a family tree of branches, but if the trunk fails, big sections die. Hybrid topology. Real-world networks often mix topologies, star plus mesh plus tree. This balances cost, speed, and redundancy. There's a physical versus logical topology. Physical. Actual layout of cables and devices. Logical means how data flows regardless of wires. Example, a Wi-Fi network physically looks like a star, everyone to the AP, but logically it acts like a bus. All devices share the same medium. Hacker's perspective. Bus. Shared media. Attackers can sniff all traffic easily. For star's central hub is a juicy target, one compromised switch, your whole network exposed. Fogeturing wire, denial of service by breaking the loop. Fomestio harder to attack, but routing protocols become targets. A treek, hit the root, cripple the branches. This is why topologies matter not just for design, but also for defense. The real-world examples, your current home Wi-Fi lures star topology, all to the router. Older Ethernet labs and bus topology with coaxial cable. Bitcoin peer-to-peer networks more. Partial mesh for resilience. Corporate data centers. Hybrid, star plus mesh plus tree for scale and redundancy. Forward, try it yourself. Draw your home network on paper. Your ISP modem, router, phones, PCs, smart TVs. Which shape does it look like? Most likely a buster, but if you add mesh Wi-Fi extenders, it becomes hybrid. Fourier. The big picture network topologies are the skeleton of communication. They decide whether a failure is a paper cut or a total collapse. For ethical hackers, knowing topology means knowing where weak points live. For defenders, it's the blueprint to secure. This was episode 15 of the DHT Ethical Hacking Mega Course. I'm DHT Ghost. If you learned something new today, smash like, drop a comment on what topology your home or office uses, and subscribe for more. In the next episode, we'll explore client-server architecture, the silent deal behind every app you use. Stay sharp, stay ethical, and I'll see you in the next one.